Hi everyone, thank you for joining me today. We're going to look at a few different calculus concepts by looking at a simple example looking at how the area of a rectangle changes. We know the area of a rectangle is its length times width. And we can see to the left that the original rectangle is shaded in gray. And what we want to know is what happens when we change the length by delta L and the width by delta W. What is the change in area from our original rectangle? And what is the area of the new rectangle? The new rectangle is outlined in blue. So we're going to take this a step further. Originally, we know that the area is length times width. We can see that here our new length is delta L times L, and our width is width plus delta width. So our new area formula is going to be those two multiplied by each other. So we can expand that out, showing our final area is length times width times delta length plus length times delta width times delta length. But where do each of these pieces come from? So the area of the rectangle our new rectangle has these dimensions. So originally we see where the length times width comes from. The width times delta L is that top left corner where we have the base of that, or the one dimension is the width, the other dimension is delta L. That top right corner is delta L times delta W. And to the right, you have length times delta W. So our new area is the sum of all of those four pieces. So the change in area is just the region in white. We're going to subtract out the shaded region, our original rectangle. In doing so, we're left with the change in area equals width times delta length plus length times delta width. So what happens when those two changes get really small? As they get really small, they approach zero. And then those two multiplied by each other is essentially zero, because it's the smallest number you can think of times also that smallest number. And as this happens, you're following that limit out with those changes. So as this happens, your deltas, your differences, become infinitesimals. That infinitesimal change in the length and the infinitesimal change in the width. So the change in area could be represented by the derivative of the area of the rectangle. So how does the area change is going to be width times delta length, or dl, plus l dw, and that is your change in area. So what if we did an example, just to illustrate this idea of what happens with the two L's. And just, if you wanted to do an example and you tried your length as originally 10 feet and your width is 5, and you want to change both length and width by half a foot. So we know original area would be 5 times 10 would be 50 square feet. Our new area then is 10.5 times 5.5, which is 57.75 feet squared. Let's think about where each of those pieces come from. So let's go back. So originally, that area in the middle, that shaded gray area, is the 50 square feet. How much is that top left piece? Well, it's your 5 feet times your half a foot, that change in the length. So that would be 2.5 feet. How about your piece on the right? That would be your original length, 10 feet, times your width, 5 feet. So that is 5 feet, or your change in width of 0.5, which is 5 feet. So you have 7.5 feet plus 50 feet, so you get 57.5 feet squared. Where's that other quarter of a square foot come from? That's that tiny square up in the top. As you can see, as this gets really small, that's the smallest part. So if we didn't include it, we're not very far off from what our answer would be. So this is the problem with then extrapolating out the change. We're neglecting that little rectangle in the top right. If the changes are really big, we're off by a lot. But when the changes are small, we're good. And we're very close to what the answer would be. So what this example illustrates is the product rule, which is what happens when you have, so if you have a function f of x, which is which is equal to function g of x times some function h of x, and you want to know how that function changed, it is as what's learned in introductory calculus, it's the derivative of the first times the second plus derivative of the second times the first, which is essentially what we just showed here with our change in area, which is width times the derivative of the length plus length times the derivative of the width. Thank you for joining me. I'll see you in the next video.